Hello, my name is Muhammad Azim and my groupmate Denny and Putri. So we are going to present the lab report E2, Common Emitter Amplifier. The objective of this experiment is 1. To measure the input and output impedance of a common emitter amplifier. 2. To determine the power gain of the common emitter amplifier. 3. To determine the phase relationship between the input and output signal of the CE amplifier. The equipment that we use in the experiment is first 9V DC volt power supply, dual channel oscilloscope, digital multimeter, function generator, project board with connecting wires, resistor, potentiometer, capacitor and transistor BC108. To get the exact circuit like the prelude, first the color code for each fixed resistor used in figure 1 was written. Second, the circuit shown in figure 1 was constructed. Rout is removed from the circuit for this section. Third, point A and point B were connected with a jumper wire. The frequency for the function generator was set to 1 kHz. The output signal at point D and C was observed using an oscilloscope. Fourth, the potentiometer R12 and the amplitude of the function generator are adjusted until the input signal is made fully visible. Fifth, R12 was removed. Its two resistance values were measured using a multimeter and were recorded in table 1. R12 was reinstalled and the amplitude of the function generator was gradually increased until the shape of the output signal began to distort. 7. The amplitude was reduced to 70% of the value at which the distortion had occurred, and the value was recorded in table 1. This voltage level is called Vout. The function generator amplitude setting was not changed until this experiment is complete. For part 1, this is analysis. First, the function generator was turned off. Second, the DC voltage between the base of Q1 and ground was measured. VB equals to 4.05 V. Third, the DC voltage between the emitter of Q1 and ground was measured. VE equals to 3.84 V. Fourth, calculate the emitter current. IE equals to 6.86 MA. Fifth, the DC voltage between the collector of Q1 and ground was measured. VC equals to 4.03 V. Sixth, the collector to emitter voltage VCE of Q1 was calculated. 7. The measurement of calculation in step 2 to 6 was filled in table 1. So this is the table 1 value. Part 2, the input impedance Rin of the CE amplifier. First, the function generator was turned off. Second, the jumper wire was disconnected. Third, the voltage across the input resistor was calculated. Fourth, the input current was calculated. The input resistance was calculated. Sixth, the voltage was calculated. 7. Vin and Vout was sketched in the same graph. For part 3, the output impedance Rout of the CE amplifier. First, Rout was inserted back to the circuit and the potentiometer was adjusted until Vout is half of the value obtained in prelude. Second, the Rout was removed from the circuit and the resistance was measured using a digital multimeter. This value is equal to the output impedance of the amplifier Rout. Third, the value was recorded in table 2. Fourth, comment was wrote down to justify step 1 and step 2. For part 4, the power gain of the CE amplifier. Based on the value in table 1 and the definition below, the input and output power and the power gain of the amplifier can be calculated. For A, this is our formula, and this for B formula, C formula and D formula. For part 5, the effect of a shunt capacitor C3. First, the shunt capacitor C3 was removed from the circuit. Second, the output voltage Vout was measured. Third, the effect of this capacitor was explained. Fourth, the real picture of the waveform obtained was captured. So this is our table of the measurement. The last part, which is part 6, the phase relationship between the input and output signal. First, the capacitor C3 was placed back to the original position. Second, both channels on the display were used to display the input and the output signal of the CE amplifier. Third, the actual waveform image was captured and saved in smartphone. Fourth, the phase difference between the two waveforms were determined.
And now we look at the calculations. For part 1, the value of BB, BE, IE, BC, and BCE are calculated. For part 2, IN, OUT-IN, and AB are calculated, and the transistor operations are shown here. DC load line analysis, common emitter configurations, and the Q point of transistor operations is determined, and the graph is brought here. B-in and B-out wave signal and their attitude based on the experimental setting are scattered on the below graph. For part 3, we have the output voltage so that the load equals the amplifier internal output resistance. Remove the load and measure it, give the actual output resistance. For part 4, the P-in, P-out, AP, and AP in dB are calculated. For part 5, the shunt capacitor C3 increases the AC gain by providing a low amplitude path for AC signal. It moves the output, reduce noise, and improve the waveform stability. When C3 is removed, the AC gain drops, and the output becomes smaller and noises. The real pictures of the waveforms obtained is captured. For part 5, the actual waveform image is captured and set to on-thumb drive. The output of a common emitter amplifier is impacted with respect to the input. The phase difference is 100 degrees Celsius after calculations, and the phase difference between two waveforms is equal to 118 degrees Celsius. For tasks and questions, the common emitter circuit is used mainly as a voltage amplifier. The input AC signal is applied between the emitter base. The AC voltage gain is high. The output impedance is high. The two applications of common emitter in daily life are speaker and smartphone.
For discussions, in this experiment, we study the performance of a common emitter amplifier, which is a bipolar junction transistor, to improve the voltage signal. The key idea is proper transistor biasing. We set a stable Q point so the amplifier can handle AC signals without distortion. First, in part 1, our DC measurements at the base, emitter, and collector confirmed that the transistor was operating in the active region. This meant the amplifier was ready for clean AC amplifications. In part 2, we measured the input impedance Rin by observing the AC voltage at the input. The result showed the typical behavior of a CE amplifier, which is a loading effect and a high voltage gain with a clear 180-degree phase inversion. In part 3, we found the output impedance using the half voltage method. When the output dropped to exactly half, the external resistor values match the internal are out of the amplifier. Next is part 4. Our power calculations confirm the amplifier not only increase voltage but also boost the AC power delivered to the load. As for part 5, adding a shunt capacitor significantly increased the gain by reducing AC emitter resistance, giving us a larger and cleaner output waveform. By removing it, brought the gain down due to negative feedback. Finally, our oscilloscope reading shows smooth amplified signals with the characteristics 180 degrees inversion, proof that the amplifier was working correctly. We did face some errors, mainly from biasing mistakes and difficulties adjusting the high voltage point. This can be avoided by checking resistor values, securing connection, and minimizing movement during measurements. In conclusion, our measurement shows that the common emitter amplifier performed exactly as expected, although we had some difficulties to do the experiment. The input impedance of the amplifier was found to be 89.3 ohms, while the output impedance was approximately 5 kilo ohms, by confirming the typical high output and low input behavior of a common emitter amplifier. The amplifier also delivered a strong power gain of 38.7 decibel, demonstrating its effectiveness in AC signal. And finally, the oscilloscope readings clearly show a 180 degrees phase shift between the input and output, which is the defining characteristic of a common emitter amplifier. For these discussions on common emitter amplifier, we refer to the articles and resources from LProCast, Wikipedia, and all of our circuits. We explain their working characteristic and practical applications.